Ashley began a new summer job earning $10 an hour. If she works over 40 hours a week, she earns time and a half or $15 an hour. If she earns $15 an hour, then she has worked over 40 hours a week. We can let P represent the sentence Ashley earns $15 an hour, and Q represents the sentence Ashley works over 40 hours a week. If P then Q would then be, if Ashley earns $15 an hour, she has worked over 40 hours a week. And if we did the converse of that, if Q then P would be, if Ashley works over 40 hours a week, she earns $15 an hour. In this case, both the conditional and its converse are true. The conjunction of the two statements is called a biconditional. Prefix bi, to, conditional. It can go either way. A biconditional statement is the conjunction of a conditional and its converse. It can be written symbolically if P then Q and if Q then P. And it is also written P if and only if Q. I've had lots of people try to tell me that I've typoed, but if and only if can be abbreviated IFF. So the biconditional statement is as follows. Ashley earns $15 an hour if and only if she works over 40 hours a week. So the biconditionals work well for things that are definitions. The first example we look at is a good case of that. They're going to ask us to write each biconditional as a conditional and its converse. Then determine whether the biconditional is true or false. If false, give a counterexample. Two angle measures are complements if and only if their sum is 90 degrees. One way we could start off with a conditional statement is to write, if two angle measures are complements, then their sum is 90 degrees. If that's our original conditional, then the converse, we're going to reverse the hypothesis and conclusion of the original statement. So we're going to have if the sum of two angle measures is 90 degrees, then they are complements. The definition of complementary is the sum of the angle measures is 90, so the original is true. And if the sum of two angle measures is 90, they are complements is true also. So the whole biconditional is true. Of course, that will not always be the case. For this one, we could write our original conditional as if x is greater than 9, then x is greater than 0. That, of course, is a true statement. The converse, switching our hypothesis and conclusion, would be if x is greater than 0, then x is greater than 9. That is not a true statement, and for a counterexample, I could use x equals 1 is greater than 0, but is not greater than 9. So that means the biconditional is also false. Summary, to write a biconditional statement, you're going to take an if and only if statement apart and write it as a conditional and its converse. To write a converse, you reverse the hypothesis and conclusion.